Hello and welcome to this R tutorial. So in the previous tutorial we learned a very efficient way to evaluate our model performance. So that was about evaluating our model performance, and in today's tutorial we are going to learn a technique that is going to be about improving models performance. So we already built very powerful models, but we can still improve them. And how can we do that? Well, it's by finding the optimal values of the hyperparameters. Because indeed, any machine learning model is composed of two types of parameters. The first type of parameters are the parameters that are learned through the machine learning algorithm, and the second type of parameters are the parameters that we choose, like for example the kernel in the SVM model, or the penalty parameter, or even some regularization parameter in rich regression or lasso. And basically in any machine learning model we have a lot of parameters that are not learned. And so far what we've done in this course was just to choose one single value for these parameters. We never actually experienced with these hyperparameters. We never tried several values of them. And so that gives us still a lot of room for improvement, because maybe there were better choices for the values of these hyperparameters, a better choice than the value we chose. So this technique called grid search will answer to one of your questions that were asked many times in this course, which is, how do I know which parameter to select when I make a machine learning model? What is the optimal value of these hyperparameters? And grid search will give an answer to that, because it will find the optimal values for these parameters. So let's see how it will do that, and let's implement grid search. So we're going to work on the same problem as in the previous tutorial. That is, this classification problem where we need to classify the users in the social network and predict if they're going to click yes or no on the ad to buy the SUV. And therefore we are working with this data set, social network ads. And besides, that's a good example because the kernel SVM model has many parameters. It has this penalty parameter, this gamma parameter, and some of you asked me which values we should choose for these parameters. And so grid search will tell us exactly that. So let's do it. We are working in the same folder as in the previous tutorial, that is the model selection folder. Make sure that you have the social network ads CSV file, and if that's the case, you're ready to go. So we are going to apply grid search anywhere after the data preprocessing phase, because we're not actually going to use this kernel SVM model and then doing some parameter tuning on it to find the optimal values. We're actually going to use a new package that you will see is a very practical package to build the same kernel SVM model as this one here, but by applying grid search on it at the same time. And this package, you already know it, it's the caret package. And really, when we talk about machine learning in R, the caret package is one of the most practical packages. Because basically with this package, you can build any machine learning model. And not only you can build any machine learning model, but when you build a machine learning model with the caret package, well, it will give you the model you want with all the optimal parameters. So that's pretty powerful, and therefore that's one of the most powerful packages in R. So as I told you, we can build this new tuned model anywhere after the data preprocessing phase. So let's actually make it right after the k-fold cross-validation section to, keep the other interesting code sections here, so that, for example, you can compare the two models, the one we made here and the new model we are about to make with the caret package. Feel free to compare their performance results. So we're going to build this new kernel SVM model right here. So applying grid search to find the best parameters, I prepared this code section here, but actually it's not only applying grid search, it's also building a new model. So the first thing that we have to do is to import the caret package. We already installed it in some previous tutorials, but let's make sure you install it if you didn't follow those previous tutorials. So I'm just putting back this command, and inside, of course, caret in quotes. All right, and then I'll put that in comment. Here we go. And now let's import the package with the library command. Here we go, library and caret inside. Perfect. So now let's build the same kernel SVM model, but with the caret package. and you're going to see that it's going to be something new. Okay, so since we're building this new classifier, the kernel SVM classifier, well, let's call our model with the usual name, that is classifier. Alright, so that's the variable, and then equals, and then that's where we use the caret package. And what is the function we're going to use now? It's one of the most used functions of the caret package. It is the train function. So parenthesis, and now what's really interesting to do is to take a browser, here it is, and let's type caret, enter, and let's take the GitHub link. So let's click on it, and inside of it, you need to click on this link right here. And then let's click on 6 available models, because in this section, you'll get all the models you can build with the caret package. And there are a lot of models. They're actually all the models we built in this course. So right now, some of you might be thinking, then why didn't we build all these models with the caret package? Since indeed the caret package will give us these models with the best optimal parameters. Well, that's because the packages we used to build all the models in the course have great options, some of which you cannot use with the caret package. So it's good to know how to use both the packages we used before in the course and the caret package. But definitely, for parameter tuning, you should use the caret package. Alright, so this list you see here is the list of all the models you can build with the caret package. And since right now we're building the kernel SVM model, well, you will see that it is available. I mean, it is part of this list, and we can find it right here at the bottom of this list, because indeed we can see that we have many support vector machines model, and the one we're interested in is the support vector machines with radial basis function kernel. Remember, the radial basis function kernel is the Gaussian kernel, the most commonly used kernel to build a kernel SVM model. And so this is the model we are going to build right now with the caret package. And the information that we need to take right now, that is going to be one input of the train function we're about to use, is this information here. That's the input of one of the parameters of the train function, the method parameter, and it is with this parameter that the train function will know which model to build and which model to tune. So right now what we have to do is to take this name, copy it, and we will paste it as input of the method parameter inside the train function. So let's go back to RStudio. Here we go, and now let's build the model. So we can actually press F1 here to get the information of the arguments. So let's see what we have to input. The first compulsory argument we need to input is this form argument. And of course, that's the formula. So let's do it. Let's input this first argument, form equals, and then we need to put the formula exactly as we used to do when building the previous models. So that's the dependent variable, which is, as a reminder, purchased. You know, it's the social network ads business problem. So here we need to input purchased. Here we go. Then tilde, and then all the independent variables. And remember, we don't have to put the names of all the independent variables. We can use this shortcut here, that is this dot. All right, then comma, and then next argument. So the next argument is data, and that's of course your training set. You're building your classifier on a training set, and so you need to input here data equals training set. Here we go. So now with the form, the formula, and the data, the training set, you have all the information you need to train your model. But then of course, we need to specify which model we have to build. That is, we need to specify that we want to make the kernel SVM model, and that's what happens with the third argument, which is not one of these arguments here. These are not compulsory, but it's the method argument. Actually, you have the link here, the link we just browsed on Google. This link will give you the list of all the models available in caret. And so that's for this method parameter that we need to input what we copied in this link, that is SVM radial. So let's input that right now, comma, and then method equals, then quotes, and inside of these quotes, we need to paste SVM radial. And that's actually all. With these three arguments, the formula, the data, and the method, you will build a kernel SVM model. And then for the parameter tuning, you're going to see what happens. So first, what we're going to do is execute the data preprocessing phase because we need to import the data set and applying the data preprocessing phase. So let's do it right now. We're not going to execute these sections because this is to build the kernel SVM model the other way. So we just need to take everything from here up to the top. Here we go. Let's do it. All right. Data set well imported. We have the data set, the training set, and the test set. And the data preprocessing phase was applied all correctly. All right. So now let's build the kernel SVM model with the caret package. So let's make sure we import the caret package. Here we go. And now let's select this line and execute it. All right, it's taking a little time. Well, around 1 second, that's fine. And here we get our classifier. So that's the kernel SVM model classifier. It is not yet tuned, but you're going to see what's going to happen. Because now what we're going to do is pressing enter here. And we're simply going to type classifier and selecting this and pressing enter. And there you get a lot of very interesting informations about your kernel SVM classifier you just built with the caret package. Because indeed, what you see here is the conclusion of some parameter tuning that was done on this kernel SVM classifier you just built. And what is this conclusion? It is that accuracy was used to select the optimal model using the largest value. So that means that the accuracy was the performance metric to evaluate your model performance. And just below you see that the final values used for the model were sigma equals 1.12, 1.13, and C equals 0.5. And that's the result of your parameter tuning. That's the optimal values of the hyperparameters of the kernel SVM model, the ones that will make your kernel SVM model even more performant than the one you built with the previous method. Because of course, maybe the default value for the C parameter was 0.5. This looks like the default value, but definitely the default value for the sigma parameter, which is another hyperparameter of kernel SVM, was definitely not 1.13. And with this 1.13 value for the sigma parameter, you get the optimal accuracy. An accuracy that is higher than the accuracy you obtained with the kernel SVM model built previously. And you can even see what this accuracy is. It is shown right here. Accuracy is 92%. And besides, this is a relevant accuracy. This is not the accuracy measured on one train test split. This was measured on several train test splits, which you can exactly see here with this information resampling bootstrap with 25 repetitions, which is exactly the same principle as k-fold cross-validation. That means that you take different samples of training sets and test sets, and you build your model on the training set and test its performance on the test set for each of these samples. And eventually you take the mean of the accuracies and you get a 92% accuracy. So that's definitely a good accuracy, and besides, that's the best you can obtain with these optimal values of the hyperparameters sigma equals 1.13 and C equals 0.5. And now I'll give you an even faster way to get these optimal values of the hyperparameters. You just need to, well, let's keep this classifier here, but let's copy that. You just need to take your classifier and then add a $, and then you can add here best tune. Here you go. You select it, you execute it, and you get directly the optimal values of the hyperparameters. Sigma equals 1.13 and C equals 0.5. And now congratulations, you got your best kernel SVM model with the best train coefficients and the best hyperparameters. And now the choice is yours. You can either take this kernel SVM classifier you built here with the caret package, or you can take the classifier you built here was the usual way, but inside of this SVM function, you can input the optimal values you found here for the hyperparameters, that is, sigma equals 1.13 and c equals 0.5. I will let you that for practice and judge yourself which method you want to choose, and I'll see you in the next and last section of this course, in which we're going to implement one of the most powerful models in machine learning, XGBoost. So this is going to be a very exciting section. I can't wait to see you there, and until